Hello everyone. I think this is my first tech talk things. So let me introduce about myself. Actually, I am not yet a psychiatrist. I'm still under training. So yeah, if you have any imposter syndrome or you have any, depression, yeah, you can talk to me. I offer free psychotherapy for one session. Do you anyone who already understand the Elixir, the language? Anyone? Okay. So it might be a little boring if you understand the Elixir language. Today's talk is about introduction talk. It's talk about a little bit how to perform recursion, write recursion well in Elixir. If you're coming from Ruby or Python, it is totally waste energy or performance if you write recursions. You will take a lot of stack there. So, but in Elixir, okay. So why me? Why I talking this? We are Homo sapien, right? But there's a book. I think it's maybe 70 years ago. It's called about Homo ludens. Every people, okay, learn things from play. So why me? Because I like to play in the language things, and because it's an introduction course, I will from the beginner's mind to introduce Elixir, this language. So the first day you learn Elixir is from this page, right? You go to the Elixir land and you click in the guide and you read all of it. You understand, yeah, recursion is kind of cool stuff. It is not the same as Ruby, but it looks like. It's not the same like a Python or other object-oriented language. Is functional. Yeah, so you read all of them and you start trying to practice. So I think you will go to the exercism, right? To try to write the first hello world. Yeah, hello world. And then maybe you have some kind of event of code, right? 2017, 2016, and then you have some, problem. So you go back to read that again. Oh yeah, I'm really, really sure I understand the recursion things, but I'm not writing it very well. I still have some problem. So you read another books. The book say, I think outside there's a bookstore. There's a book called Elixir in Action. I see some people buy that just before the break time. Inside that is a construct such as while and do while unprovided in Elixir. Shit, not provided. But if you think about it, they can work given the data is immune. Oh no, I can't handle it because I can handle. But what will I do? So there's a guy, I think is kind of a Lisper Aladdin entrepreneur things. He said about to iterate is human, to recurse divine. It is that we human think things in iterating way. But if you want to be more, if you check the natural things, it is all recurse patterns. So if you want to be some kind of God human, you can learn the recurse, so you will be some kind of divine things. Okay. So any program have to need a way to do a loopings. But in Elixir, the principal looping is only recursion. So forget about iterate. So we will do iterate with recursion. So how do we have more knowledge about the recursion? First, we come to this book. This book is called Little Skimmer. I think today's Christopher talking about skin is not a skin book. Although skin is this dialectic book, but this book is not talking about Lisp. It's not how teach you how to do the Lisp. I think it's one of the best, the recursive thinking book. I don't know there's another one. But you don't have to learn a scheme first. If you open this book, it's like kind of, they have some comic books and they have some describe in human language. So you need to do to translate the human language into code. So you can do it with a Lisp. You can do it with, I think Clojure is okay. Haskell, all the functional program, they all have the feature of recursion. So if you really want to buy this book, there's a Tianlong Shudian is our store later, but they don't put this book out today. So it's not too far from here. It's about 90 meters away. So you can walk there to buy this book, or you can buy it from the Amazon or MIT process, or you can find it on Google. But before we start, because there are few people read Elixir before, so I will try to talk a little bit about the pattern match and the linking list. The first is pattern match, like this one. This is code tuple, like this one, A, B, C. The equal sign is named by the match, pattern match. This is not a sign, it's a pattern match. The equal sign is pattern match. Pattern match with hello, world, and 42. So right now, A is hello, and B is the world, so C is 42. And today, we will see a lot of pattern match in functions. I will talk about it later. So remind is the pattern matching. And the other one is linking list. It's totally different from the Ruby or the Python. The list is not a list. It's not kind of array. It looks like this. It's called 1 through 1, head and tail. For example, the list 1 through 3, true. Actually, it looks like leaks. Pointer, no. True. Sorry. The 1 through 3, actually, the total structure is look like that. This is called head. The head of this 1 through true and 3 is head is 1 and the other is tail. We will use these patterns all over this talk. And the other one is items. Actually, it's kind of like string things, but I think in Ruby it's called symbol, right? I'm not sure. So this is item. Okay. So if you want to write some code, I have posted on GitHub. You can search the Polygon or Schema and Schema or Elixir. There were lots of GitHub repo there. You can try it on your own. So before we start, we have the 5 basic rule. One is the car. Car is taking over head, and the CDR is kind of return the tail things. And cons is put the head and tail together to build a new list. And the equal is like if it's open. Okay, so the equal function is pattern match, right? If the equal AA, then we return the true. And if it's equal A or A and B, then we return the false, right? This is a pattern match. You can write the function of the same name, but receive different parameters on the rule. This is you can do in Elixir. Like the last one is null. Null, if it's an empty list, then we return the true. And the bottom line is anything else, we will return the false. So this is a 5 basic rule. Now, if you want to do the recursion, you remember the 10 commandments from here. Okay, actually it's 15, but the ones don't block. So, okay, so that's the 10 commandment. The first question you want to write the recursion is ask null. Like this example, you can think about it. If A is the open commit, and I want to ask the A is inside the list, is it inside the list or not, and return the true, how will you do? Yeah, this is, you always write the recursive function start from the null. You will see all the pattern of all the 10 examples. So look like the first one, the null. If for the null, return the false, because the list must have an ending, right? So the ending is the empty list. You have to think about the termination condition first. So if the termination is a number is a 0, and you return a 0. If the termination condition is 1, then we return 1. So that's the first pattern you have to remember. The second, use counts to build the list. So let's go back to this example. Like the 1, 2, 3, the third, the last one. Also, this is not a good example. Okay, this one. A is a mint. I want to remove the mint from the list. So how do we do? How do we write the code? So first, the null condition, I do it. And the second, if the word the same, I only return the tail, right? And the third one, that if the word is different, I have to put the head inside the new list and return to call another remember function here. So like the purple line later, there's a count. You build a list with the count. Okay, so remember they have a two part. First one is the first typical element, and the other one is a natural recursion. So like this example, there's a list inside a list. Okay, I want to take the inside list, the first element of the inside list. So I want to take AB, take the A, CD, take the C, and EF, take the E. So we will return the A, C, E. How do we do that? So we first always return the empty list, and then we have used some pattern match things, the head list and the tail lists. Okay, head list, we want to tell the first head things. So this is our first typical element. And this is a natural recursion, and we use the count to build our recursion. So like, I think like this one, the remember one, the head, the less remember function, the head, we build the function with the first typical element, and the remember put the word and tail to build the first and the natural recursion. Is that clear? Okay. Okay. So now remember you change one argument, at least one argument. Change one argument and then you come to a termination. Okay, look at this example, okay? We want to change the mints to monkey. Okay, I want to change all my lists. If it counts as a mint, I want to change to a monkey. So we think in recursive way. First, we write the empty list, right? And then we want to, from the first one of the list to the last one. How do we do that? We have to change one by one. Actually, you can change 2 by 2 or change more things, but at least we want to, our goal is empty list. So I have to remove one item at the time. So how do we write this function? First line is an empty list. Right? If I don't care anything, if the list is empty, please return empty. And the second line, second multi-subst, is that if the word and the target is the target is the same, please return the target. Please replace the target to the word. And the third one is that if it's a different, so kill the different things. You don't have to replace it, and we build it with the count. With the pipeline, this is build the list. The first one is the natural return. The other is the natural first typical element and the natural recursion. Not only the list, you can do it with other numbers. For example, if a list, you always consider termination line is an empty list. We talk about it a lot. If it's a number one, if it's building the value is use multiple things, you always use 1. And if it's a plus thing, you use 0. Let's look some example. By power, yeah, we can do power use recursion. Like power maybe 2 power 3 is 8, 5 power 3 is 125. So how do we do it? We found 1, right? If the termination is 1, then we return the n. And others, we will first return the n, and then the n minus 1, they put it into the natural recursion things. So what is the termination condition? You have to think first. And divide it, you can do it with from the 0. You have built it from the 0. Like the list of the list. You also can use the termination condition is 0, right? If it's empty list, I want plus 0. So if any element inside the list, I will plus 1 and the minus 1, right? So like if want to pick, pick one, pick the list. I want to pick the number 4. How do we do it? We can write it in recursive way. If it's empty list, we return nothing, just empty list. And if the pick number is 1, I will pick the head, right? Number 1, I want that. If we have to pick n, then we ignore the head because that's not what we want. And we pick the tail. And then the number minus 1, then to do the natural recursion again, right? We want to close to the termination, okay? So, is it okay right now? We are on the halfway, okay? Already finished. Then if you want to simplify the function, you have to wait until the function is correct, and then you simplify it. And that's a much difficult part. That you can recurse on the subpart, like lists inside a list. You can recognize that pattern, then you can recurse it. Like this one. This is easy one, right? And we recurse on the list inside the list. So we take that out and then put it into the head. There is another example I will explain again. And then you want to use some help function to extract some representation. Okay, like this one. This one is called numbered. I want to count the numbers. So actually, the numbered is a help function, and I want to return some value. If I have lots of like a y have a 1 and have a plus and have another, another list with a number, and the middle side is the operator things and another numbers. Actually, this is a sublist. Here, this purple frame is a sublist. We have understand this is a sublist, and inside it, the multiple symbol is a sub expression. You have to recognize it and then extract it. So how do we write this programming thing? So first, we have write some helper functions. Like if it is plus, then we do the true, and it is multiple things, we return the true, and it's a power thing, we also return the true. And other AO symbol, we want to return it false, right? So, okay, so we want to, take the value. There's the left side, right? And the operator inside, and the right side. I write it 3 times. It is totally waste. So you can extract these patterns. I will show, this is the next one, right? You can extract all the pattern things. But we back to our first line, the numbers. So there's a left side and the operator and the right side. So I want to ask, is a numbered question mark left side? So if it is, we can do a pattern match, right? If it is a number like 5 or 2 or 3, then we return the true. We can ask the is number, and then we return the true or not, and we go to the middle part. And then if the left part is a sublist, have a number, have an operator, is another list, we will recurse again and again inside it. So it can be a very complicated, list. Maybe have 10 lists inside of it. So we can do recurse on it. Just use this simple functions. So I say I want to extract the pattern, right? So like the value things, the value line before that is left and plus and right. I write it 3 times. So I want to extract that one. So I call it get value. I write it here. In the Elixir, you can return functions. Function can return functions. So I use the operator here that altern 2 functions. If it is a plus, I will return the plus function. If it is a power function, I want to return the power function. This is built inside the Elixir. But power things, there's no power function in Elixir. So you have to call back to call the erlang function. So you want to call the erlang, it's an erlang module called math. You can call the math and power. So then I get value things, I can use the operator. I can use operator and then extract the function and then I put the left and the right side. You can do it to extract the repeat things. So the last one that you can build functions to collect more than one value at a time. Like this one. The list have a left side and a right side. I want to insert the Z into the left side and the right side, right? So I have to do 2 operators in one, in one step. I have to insert 2 altern into a list in once. So how do we do that? Like we said before, we can recurse a pattern 1 by 1. So first, I want to always as a null, right? The null, if this is empty list, so return the empty list. Do nothing, just return the empty list. So now, if the first I want to deal with the left part. So if the left part is the same of the left part, so I will remove it and put it in a new one. Not remove it, sorry. I just insert it to the left part. So if it's the right part, then I will insert it in the right part. And if not the right part and not the left part, I just do nothing. I just return it. And then I will build it 1 by 1 with the count function, with the pi operator. And then there's the first typical element, and the rest is the natural recursion function, right? We can do it like that. So I know after the 10 commitment, you may feel confused. So my best thinking that you don't even have to buy that book. You just go to a GitHub and type the keyword, the Elixir and the little schema, and then you can get some practice on your own. You can understand what I'm talking about today. Why this one is so important? Because like the building block, like Legos, recursion is a building block of Elixir. Because in Elixir there's no things to store the state. You have to use process, like the recursion things, always running on that, like process to keep the state, to save it. So if you use a Gen server or other OTP framework in Elixir, then you will use the recursion. You don't have to write recursion when you use these tools. It will write it for you, but you have to understand that the recursion is a power behind that. So use the source, use the recursion. So this is my last slide. So may the recursion be with you. So thank you.
Does anybody want to ask any questions? Okay, well, that concludes our